Okay, so in this video we're going to be looking at the proof of a plus b on 2 that's greater than or equal to the square root of ab. So in this question, we're essentially required to show that this is actually the arithmetic mean and this is actually greater and equal to the geometric mean. If you remember from statistics, that's how we define, it's actually a property of the arithmetic mean, it's always greater than the geometric mean, and we're asked to prove this. So this will actually be the foundation for a lot of the proofs in this topic of harder 3 unit and I guess real analysis. So the way we actually like to go about this, we like to work backwards from, I guess, manipulating this expression somehow, and I guess moving back from that same manipulation. So it makes sense when I do it. So for example, I just write out what we have again. And so what I mean by that is we'll just play around with this and see what happens and where it gets us, so we can I guess show like a proof of this kind of this property of the geometric mean and arithmetic mean. Cool. So expanding both sides, I can square this. A plus b all squared is greater than or equal to 4ab. And then I can expand this, and that becomes 2ab plus b squared is greater than or equal to 4ab. Yep, and then we just move this guy to the other side. We get 2ab plus b squared is greater than or equal to 0. And then a minus b all squared is greater than or equal to 0. And this is what we needed. This is actually a given fact. So we can write this as a fact, because we know that any number, and you square it, means that it actually is going to be greater than 0. I mean positive. Cool. So what we're actually required to do, so this is just our working, right? All of this we just got to was to get this fact. So now what the actual proof is actually working back from the fact and moving in such a way that we kind of get back to this expression. So this would be on like the side of our page, right? So pretend like we did all this working, maybe on the side of our page. Cool. And our actual proof of the question would be over here. So I'll just write proof and we'll go about that. Now all I'm going to be doing essentially is starting off with the given fact. So a minus b is greater than squared is actually greater than or equal to 0, and we know this is true because any number squared is greater than or equal to 0. And expanding this now is greater than or equal to 0. And then now we can add both sides by 4ab. So this becomes a squared minus 2ab plus b squared plus 4ab greater than or equal to 4ab. And we can do this because 4ab is actually a positive number, right? So in this question, I guess it's meant to be assuming that a and b are both greater than 0. And with this, 4ab is obviously greater than 0 because 4 is positive and a and b are both positive. Okay, now simplifying, we get a squared plus 2ab plus b squared is greater than or equal to 4ab. Cool. And now we can actually factorize this back again. And this is that. Square rooting both sides, we get a plus b is greater than 2 square root of ab. And then obviously a plus b on 2 is greater than or equal to the square root of ab, which is that same fact that we were proving up here. We now have it, that the arithmetic mean is greater than or equal to the geometric mean. Cool. We can say QED. Nice.